Hi folks, Kevin Carey from GE's Learning and Development Group. In this module we'll be discussing the GE MDS Orbit platform and provide an overview of its key features. There are more videos available which deal with specific aspects of setting up and using the Orbit. We'll talk more about these later, but our focus here will be to provide a high-level look into the hardware, how the product can be used, and factors to consider when planning an installation. The Orbit is quite different from some of the other products you may be familiar with from GE MDS. While it uses wireless technology, the Orbit can best be thought of as a platform for an array of communication options. The exact configuration will depend on how it is set up at the factory. With this in mind, you should find it easier to grasp the concepts that will be presented here. And you'll also gain the knowledge necessary to get the most from your Orbit product. The MDS Orbit is a multi-platform wireless communication device designed for use in industrial field applications. It can be used wherever digital data must be conveyed wirelessly between sites. It connects to external data equipment such as an RTU or PLC and carries this data between remote and central sites using one of several communication technologies which meet the specific bandwidth, range, frequency, and geographic requirements of a network. It is able to use one wireless method as the primary communication link and then switch to a backup means in the event of an outage. For example, 900 MHz might be used as the primary wireless interface for a field monitoring application, but the 3G or 4G cellular platform could be configured to carry traffic in the event of a communication problem. The Orbit is a highly secure industrial-grade communications platform for mission-critical applications, and it provides operation in extreme temperature ranges of -40 to +70 degrees Celsius. It features a rugged aluminum chassis and is CSA Class 1 Division 2 approved. The chassis measures 4 centimeters high, 12.3 centimeters deep, and 19.2 centimeters wide. The Orbit provides the functions of IP routing, port forwarding, and network address translation, and it provides for 128 or 256-bit AES encryption. In this close-up view, we show the Orbit chassis, which is self-contained with all necessary hardware for operation. All interface connectors are located at the unit's front panel for easy access, and they provide reliable, industry-standard connections for power, data, and RF lines. We'll now briefly review these connectors, and more detail will be provided later regarding cabling connections. The exact layout and the connectors present will vary depending on order requirements, and a representative view of the product is shown here. Starting at the left side of the panel and working toward the right, we have the DC power connector, Ethernet jacks ETH1 and 2, a mini USB port, serial COM1 jack, cellular antenna connections, the SIM card slot, and a Wi-Fi antenna connection. Just above this panel is the LED indicator string, providing status information on the Orbit. From left to right, we have the power LED, which indicates when DC power is applied, the ETH or Ethernet activity indicator, a COM port activity light, and LEDs for NIC1 and NIC2. The NIC LEDs show activity to and from the installed network interface cards. A common variation from what is shown here is to have one Ethernet connector and 2 serial connectors. The Orbit is supplied standard with 2 flat aluminum mounting brackets, and these are suitable for use in most installations. The brackets are attached at the bottom of the chassis with 3 screws each as shown. These brackets allow mounting the Orbit to almost any flat, stable surface. Other mounting techniques are possible, including a 35mm DIN bracket and a weather-tight packaged enclosure for pole or wall mounting. The 35mm DIN bracket is commonly used in equipment racks and allows for quickly securing the unit to a rail in a space-saving arrangement. The DIN bracket attaches to the orbit by way of a channel molded directly into the case at the rear panel. No tools are needed to install it. The top image here shows the bracket installed on the unit. The lower image shows the orbit being attached to a DIN rail. To mount it, the unit is placed on the rail and the lower edge pushed down until the bracket locks into place, as shown in the leftmost image. The center image shows the unit mounted to the rail. Note that the release tab, just visible here, extends down below the case. For removal, the release tab is pulled down as shown to the right. A flat blade screwdriver is helpful for this, and the unit can then be lifted up and away from the rail. Yet another mounting option for the orbit platform is to be supplied as part of a package design similar to the examples shown here. In a package design, the unit is contained within an enclosure suited for either pole or wall mounting, including outdoors or in harsh environments. It may also be designed for tabletop or rack mounting arrangements, as the example on the right shows. The enclosure has room for many additional items, which may include specialized interface boards, a power supply, a redundant radio, and a backup battery to provide continued operation in the event of a power loss. The specific appearance, layout, and contents of a package model will vary depending on order requirements. The images shown here are simply two possible examples. Consult your factory representative for more information on package designs. We will now cover some key features of the orbit and show how it can be used in field applications. The orbit is primarily intended for use by utility and industrial customers who have multiple sites to monitor or control. Using the orbit, data can be conveyed wirelessly over a public or private network, thus eliminating the need for cabling between sites. Data sent over the system may include measurements such as tank levels, pressure readings, or electrical parameters. It might also contain status information for a control or a switch. Essentially, any data carried over a wired network could be carried over the orbit, including video surveillance data. The use of wireless carries many benefits, among them, user control over the medium, speed and ease of installation, excellent throughput speeds, and security and reliability. Although many different applications are possible, we'll now show three common arrangements for the orbit platform: cellular, Wi-Fi, and 900 MHz. The diagram here shows the orbit in a basic cellular application, where the unit is connected to three different field devices, two of which are Ethernet-based and one which is serial. The orbit acts as a terminal server for serial devices. The orbit connects wirelessly to the public carrier network through a nearby cell tower and serves as a router between the network and the field devices. Connectivity is thereby made between these devices and the central operations or data center. Note that a provisioned SIM card is required for cellular operation. This card is obtained from the cellular provider, and only one SIM card slot may be active at any given time. The orbit provides Wi-Fi connectivity and complies with the IEEE standard 802.11 B, G, and N. Wi-Fi is intended as a short-range link to provide communication with on-site devices, such as a laptop PC, smartphone, a wireless camera, or any other Wi-Fi capable device. Power output for Wi-Fi service may be set to a maximum of 20 dBm or 100 milliwatts. The orbit provides bridging of wireless devices for web connectivity or for linking with other facilities via Ethernet. In the basic example shown here, the orbit is serving as an access point for three on-site wireless devices, and it is bridging them to an Ethernet network. Note that the orbit may act as either an access point or a station. Security provisions for Wi-Fi include WPA and WPA2 with PSK and enterprise modes. The broadcast of the unit's SSID can be disabled to provide further enhancement of security. Another application for the Orbit platform is providing 900 MHz connectivity between an access point and remote stations as shown here. An Orbit used for this service is known as an MCR-900 and comes equipped with a radio module operating in the 902 to 928 MHz ISM band. This band is allocated for license-free operation in the US, Canada, and several other countries. The application shown here depicts a basic point-to-multipoint arrangement supporting a SCADA system. Other variations are possible, including a point-to-point and store and forward arrangement. One of the key benefits of 900 MHz is range. Over ideal terrain and with good antenna systems, distances of 32 kilometers or more are possible. RF output for the MCR-900 is settable from 20 to 30 dBm, and robust security measures are employed, including pre-shared keys, PSK, and Encapsulated Authentication Protocol, EAP. A variety of modulation rates and bandwidths are possible, and interference avoidance techniques are used to provide the best throughput in RF congested environments. Today, any product used in industrial communications must have a robust security suite. This is especially true in applications for critical infrastructure. The Orbit platform offers strong security measures in three realms: user security, pertaining to login credentials, physical security, which includes a tamper alarm, and network security to prevent unauthorized access or control of an enterprise. Each of these are detailed in the product documentation, but here is a brief overview. For user security, a username and password authentication is required to gain any access to the unit via a connected PC. One-time passwords, or OTPs, may also be set up so that you can log in if a password is forgotten. These are fully explained in the manual. The tamper detection feature uses a 3-axis magnetometer built into the unit that can be used to detect changes to the physical environment after installation and generate notification of the change if it exceeds configured thresholds. For network security, the Orbit platform provides a strong array of cybersecurity capabilities that may be customized to meet enterprise needs, including static routing, limiting local broadcast and multicast traffic from being shared with specified interfaces; packet filtering, preventing ingress or egress of unwanted traffic by configuring the firewall and network address translation, or NAT; secure end-to-end network links using IPsec VPN with pre-shared key or certificate-based setup; cellular security, utilizing IPsec VPN to secure an end-to-end cellular link over public networks; Wi-Fi security, securing the Wi-Fi link with a pre-shared key or EAP TLS radius using certificates; NX915 security, securing the 900 MHz radio link from unauthorized access; event logging, whereby logs can be sent securely to a central syslog server by configuring this over TLS; and finally, PKI certificate management, which can be used to generate and upload private keys and certifications for use in certificate-based security setup. We've touched on just a few applications for the MDS Orbit platform and covered them at a high level. Because the Orbit is a platform for many different technologies, new modules and applications will be introduced as development continues. In fact, at the time of this video, an Orbit ECR is being prepared for release. The ECR, or Edge Connected Router, we'll focus specifically on interfacing between public and private networks. Stay tuned to the Orbit platform to see this and other future releases. Next, we'll cover the items typically sent in an Orbit shipment and show what other resources are available for use with the product. When shipped from the factory, the unit typically includes mounting brackets as specified in the order, flat or DIN style, a DC power connector, and a quick start guide. An informational card is also supplied, explaining how to obtain the latest copy of the technical manual. Let's take a look at these items in a little more detail. The mounting brackets, if not already attached, are easily secured to the bottom of the chassis. The flat brackets shown here are secured to the bottom of the case using the screws provided. There are 3 screws per bracket. A DIN style bracket, if supplied, is simply slid into the molding channel provided at the rear of the chassis. The DC power connector is a 2-pin locking type with 2 screws for securing it to the chassis. There are also 2 binding screws at the top of the connector for securing the wires from the power source. The left side is positive and the right side negative. This is fully covered in the Quick Start Guide. As indicated on the front of the chassis, power input voltage is from 10 to 60 volts DC at a maximum draw of 4.5 amperes. The Quick Start Guide is important to become familiar with. It contains all essential information for getting the unit ready for operation. It is illustrated with key procedures and also contains important safety and regulatory information. The guide and radio shown here pertain to the Orbit MCR product. Yours will look similar in accordance with the model you have. The Quick Start Guide should be kept for reference even after installation is complete. A small card is also included with the shipment. This card tells you how to download the full technical manual for the product, which goes into much greater detail on all aspects of operation. Because of its physical size and the fact that the manual is updated from time to time, it is made available for free download at the gemds.com website. The technical manual also includes a list of common accessories that are available, including antennas, cabling, and adapters. To download the technical manual, navigate to www.gemds.com. From here, use the Product Lookup tool to locate the MDS Orbit. Once the page opens, scroll down to the Resources tab and select Manuals. The available manuals for the product will all be shown here. In this case, the 056632 A01 manual is the one that we want. You can see from the title that this indicates it is the technical manual. We'll go ahead and click that. And we'll go ahead and open it. This is a fairly large data file at 7.45 megabytes, so it takes a little bit of time to open. But you can see the progress bar. Once it does open, the file can be saved locally or placed on other media as needed. Okay, there's our PDF of the manual. And this can be printed, placed on other devices, etc. We'll go ahead and close that. Note also under Resources there are application notes, brochures, specifications for the product, and other support documents. In this next section, we'll discuss the basic requirements for installing the orbit platform in the field. We'll cover the general factors in selecting an installation site, discuss the antennas used, and show how to make cable connections to the front of the unit. No attempt is made to cover every possible installation, as this will change depending on site-specific factors. The emphasis here is on hardware, and we will later cover powering up the unit for the first time and connecting a PC for configuration. The installation site for the unit is not critical, but it should be in a relatively dust-free location, protected from the outside elements, and with ready access to cabling connections. The unit may be mounted with its standard flat mounting brackets, placed on a shelf or tabletop, or DIN rail mounted as discussed earlier. In any event, a mounting spot should be chosen where the connectors and the LED indicator panel can be easily accessed. Once a physical site has been chosen, there are three main requirements for successful operation. These are an adequate and stable power supply, efficient and properly installed antennas, and the correct interface connections between the unit and any associated data equipment. The example shown here illustrates the key elements in an Orbit MCR installation, which provides for cellular and Wi-Fi communication. Your product's Quick Start Guide and technical manual will provide additional detail for your specific unit. A variety of antenna types may be used with the Orbit platform, ranging from small, flexible antennas mounted directly to the unit to more elaborate outside antennas connected via RF coaxial cable. Two examples are shown here. With directly connected antennas for cellular service, these are main and diversity receive antennas, and a cabled Wi-Fi antenna suited for mounting in a remote location. When connecting antennas via cable, the length of coaxial lines should be kept as short as possible, and care should be taken not to pinch or kink the coax at any point along its run. The cable should be of a type suited for the frequency of operation to minimize signal loss. Again, more details on cabling are provided in the product's documentation. The cellular and Wi-Fi antenna ports on the chassis utilize small SMA connectors. In other cases, such as a 900 MHz implementation, directional type antennas may be used, and the connectors may be of different types, such as a type TNC connector. All connectors should be tightened securely, and antennas should be mounted in the clear, away from large metallic objects or other obstructions, especially in the direction of desired transmission and reception. Note that the cellular diversity receive antenna shown here is oriented in a horizontal fashion. This is done to provide improved reception for signals operating at angles different from those favoring the vertical antenna. You may need to experiment with the position of the antennas for the best reception of signals. Data cables for use with Orbit may include Ethernet, serial, or USB types, and they are used to connect a PC or other data equipment to the radio. All cables should be fitted with the proper type of connector for attachment to the radio. These are industry standard types which either snap in place with a tab or contain screws for securing them to the chassis. Connecting interface cables to the Orbit platform is a very straightforward process. In this example, we'll demonstrate by making connections to an Orbit MCR. The exact connector layout will vary depending on order requirements. Starting from the left and working right, we have the power connector. We'll hold off connecting this until the other connections are made. The power input to the unit is 10 to 60 volts DC at a maximum current of 4.5 amperes. Next is the Ethernet data connection. 2 Ethernet ports may be present on some units. This is a standard RJ45 type connector that you're probably familiar with and is used on computers. It simply pushes in and latches to secure it to the radio. Next to this is the USB port, which may or may not be used on a particular installation. It simply slips into the port using a mini USB connection. It's important to note that the USB port must not be used in hazardous locations, such as those defined as Class 1 Division 2 areas. Next to the USB port, we have the serial data ports, in this case 2 of them. Serial data may be used for both payload data and for configuration, and like the Ethernet port, it uses an RJ-style connector which snaps into place. We've connected to the COM1 port. Moving farther to the right, we have the cellular antenna ports, an auxiliary port for receive diversity, and the main port for cellular service. If cellular operation is planned, at least the main port must be connected. Using the diversity antenna will help improve reception in many cases. These connectors simply thread on and should be tightened by hand. In this case, we'll be using 2 paddle antennas. That's the diversity antenna, and same style antenna being connected to the main port. Okay. These are both secure. Next to this we have the Wi-Fi antenna port. This is a similar connector style to that used for cellular, but it is a reverse polarity with a male connector on the radio. In this case, we'll be connecting a cabled Wi-Fi antenna to the orbit using a short length of coaxial cable. We just need to tighten the connector securely by hand. This completes all of the connections for the orbit. However, you will need to install a SIM card for cellular service, and this is obtained from your cell service provider. The SIM card is inserted in a slot near the bottom of the front panel. This may be a little bit difficult to see, but it's underneath the main cellular port. And the card has a notch on one side, which will face to the left. You simply slide it in the slot, and it's pushed in until it latches. It may be helpful to use a small instrument such as a flat blade screwdriver to push the card in all the way. You will hear a click when it latches in place. We are now ready to apply power to the orbit unit. Power connector is a 2-pin type described earlier, and the wires are held to their respective pins with binding screws. In our example here, the connector has already been wired and it's ready for insertion. So we just slide it in. And we're going to go ahead and secure the connector to the chassis with these 2 screws. Now the unit is unprogrammed from the factory, so the behavior of the LEDs may vary depending on operating conditions. In this case, the power light stays lit with a solid green. With our cable connections complete, we are now ready to log in with a connected PC in preparation for configuration. There are no manual controls or adjustments on the outside of the product, so all configuration is done via a connected PC. We will not cover configuration details here, as it is outside the scope of an overview program and also will vary for each application. We will, however, show the initial login to gain access to the configuration tool. There are several ways to connect to the unit with a computer. This may be done by way of a hardwired Ethernet, serial, or USB cable, or by wireless Wi-Fi. In this example, we'll use a hardwired Ethernet cable. We've already connected one end of the cable to the orbit unit, so we need only connect the other end to the PC's LAN Ethernet port. Next, we'll open a browser window, in this case using Internet Explorer. In the address line of the browser, I'll enter the IP address of the orbit unit, which in this case is set to the default of 192.168.1.1. I press the Enter key, and it takes us to the orbit's sign-in screen. Here we enter the username and password. Ordinarily, you'll want to change these as soon as possible to something other than the default entries for security reasons. We'll use the defaults here for the sake of simplicity. The default username is admin, and the default password is admin. Next, I click the Sign In button at the bottom of the screen, or I could press the Enter key on the PC's keyboard. And with a successful login, the device overview page appears. This is the starting point for all configuration tasks, serving as a landing page for this activity. From here, you see a summary of the unit's information, a listing of any alarms or events that may be present, and setup information for interfaces. At the left of the page is a list of configuration subpages that you can jump to by simply clicking on an item of interest. The last item in the list, Wizards, provides step-by-step tools for setting specific areas of the configuration. Clicking the Home link always takes you back to the device overview page. As with other GE MDS products, the MDS Orbit platform may be ordered online using the GE Digital Energy online store. To place an order, go to www.gedigitalenergy.com, the home page for Digital Energy. Once here, simply click on Store, which takes you to a listing of all product lines. For our purposes, you'll want to use the Industrial Communications tab. Hovering over this tab displays several possible product types. You'll want the one titled Wireless LAN Extension, which is what the Orbit platform falls under. Next, we move over to the right and down the list to find the Orbit selection. At the time of this program, only the Orbit MCR series is available for order, but the list is continually updated to show the latest available products. Here we get a list of selectable options for the product. This is used to configure your order. At the bottom of the page is a list of related products and accessories often ordered with the unit. You make the selections needed for your order and then press the Login button to proceed. Logging in allows you to see current pricing data and complete your order. If you don't have a current account with us, that's no problem. You have the opportunity to create one at this time. That covers the basic steps for using the online store. Be sure to check out the other products offered by Industrial Communications, as well as the other business lines in our portfolio. Thanks for watching this overview module for the MDS Orbit platform. Here, we've covered the key features of the product, shown how it can be used in the field, and discussed the factors to consider when planning an installation. There are many additional videos available for the Orbit product line, each dealing with a specific aspect of setup and configuration. We invite you to continue your learning by checking them out at the address shown on the screen. Thanks again for watching.